Hey all, how's it going? So now we have our model running. We've looked at the hyperparameters a little bit, so we should have a fairly decent outcome. Now I want to actually build a route that we can query with Postman to see what scores we're going to get. So let's get into it. All right, so the route here should be pretty familiar considering the other routes that we've built in the past. So if we scroll all the way down here, okay. So here is the function signature. So essentially what I'm going to do is I'm going to make a get route. Since we're making a prediction, we probably could use a post route, but I'm going to keep it as a get route for now, just to keep things simple. And basically, it's going to be the users going to input things like their age, gender, back squat, all those features that we talked about, and they're going to get the predicted 5K time. Another reason that we could have done a post route up here would be because we're essentially creating an inference. So we're creating something, so that would be a post route. And if the inference took a while, then we could use a post route to make this flexible and do other things. But the inference should be fairly quick since all the weights are saved. And so now as far as the actual code of the function, it's going to be pretty simple because we want this route to basically act as just the interface. Like it's basically just going to take everything that the user passed in, and it's going to pass it to this predict run 5K, which it has a yellow squiggle right now because we haven't defined this yet. And just a reminder that because we are using Fast API, it's going to treat every parameter in here by default as a query parameter. So that's how we're going to define it in the URL. So now we'll go ahead and create predict.py. And so this is going to be a fairly simple one as well. So first of all, we're going to import joblib again, and we're going to have joblib. We're going to have it actually load the 5K predictor model that we have here. And we're keeping that outside of the function just to keep things simple so that when we essentially load the app, it's loading the weights already. So that if we had this in the function, then it would have to load it every time we call the function. So now as for the actual function itself, what we're going to do is I'm going to make the function signature right here, which is basically going to be the exact same parameters that we already have in the routes file here, which just by the way, so I don't forget, we actually want to import that as well. So I think we could just, actually, no, we have to do, yeah, from predict import predict run 5K. That works. So now that squiggle down here is going to be gone because it's defined. For the actual code itself here, so this is going to be the features that we're going to have down here. We are going to use this, so we'll tab autocomplete that. So this features, remember how we had the double bracket syntax before, which essentially made this into a column vector. That's what we need to pass to our actual prediction for the model. So this is going to end up being the list of numbers. The one caveat being, remember gender, we needed to, essentially it's 1 if it's male and it's 0 otherwise. So we just need to encode that, and we just do that in the feature vector that we're passing here. So we are grabbing the model as, remember this, a pickled object. So we essentially, it's like we have the model object that we were creating before in trainer.py. It's like we have that in our predict.py file. So we just call the predict method on that, pass in the feature vector that we have, and that is going to return. I'll just show you what it returns. So we're ready to actually test this thing. So what we want to do is we want to go back to the main directory because that's where our make file is, and we want to just say make backend. Then it loads it up here, and then in Postman. So I have a query here already that basically says it's a 44-year-old man, backshot 180, deadlift 330, etc. So we can just press send on that. So from this error, I just noticed that we never actually trained the model on the age. We're passing the age, but we're not actually. The model was never trained on it with the features. So that's why it's not expecting that feature. That's why gradient boosting has one less feature than we are passing. So what we're going to do is we're going to just open up another terminal, and we're going to go into the backend directory. Luckily, it's quick to train. So we'll just do uv run python trainer.py. Okay. So age was also not included in the query. I'm not sure how I missed that. All right. So now we've got that. So we should be okay now to go over to our Postman. Send. Oh, we also need to restart the server, and that's because joblib is loading it outside of the function. So it only loads when the server actually starts. So now we press send again. Okay, so that last error that occurred, cannot convert dictionary update sequence, that was the one that I actually wanted to show you guys. That is why we need to call index 0 on here. So now that we've done that, let me pull up Postman again. And we click send, and we'll get 1512 for the predicted time for this athlete right here, which comes out to around 25 minutes, which is probably a decent prediction. It's a little bit faster than I can do it personally, but it's probably a decent prediction given these attributes here. And the last thing to show you guys is just since I discovered that age wasn't actually put into the model, I also just did some removing outliers for that. So people that are under 18 and people over 65, I'm just not really including them. So that ended up actually improving our test R2 score. It ended up decreasing the training R2 score slightly, but if you remember, that's kind of what we want. We want these numbers to come a little bit closer together. And then, so when I rebuilt all of that and did another inference, that brings me to about 1600 seconds, which comes out to about a little under 27 minutes, which is it's still better than I can do, but it's a little bit more of a realistic time, I think, for these attributes. So looks like we have a working model with that is a decently reasonable answer. So I just wanted to show you that in this one. So thanks for watching, and I'll see you in the next one.